This is Mrs. O'Neill for AP Chemistry, Chapter 4, Section 6, Solution, Stoichiometry, and Chemical Analysis. So I know you know how to do stoichiometry problems, but now do you know how to do it in the solution sense? You should have watched the intro lesson on conservation of atoms. Here are my notes. So it says, which one weighs more, the original nails or the rusted nails? Well, the rusted nails. Why? Because oxygen was added to that iron to form iron oxide. So obviously if I'm adding something to something, I'm going to get more of it, right? I'm going to gain that weight. So here's a nice little flow chart as he always gives us. And he talked about the chemical reaction of photosynthesis. He talks about how those molecules break apart and reform. So those atoms never go away. They just break apart and reform themselves into new substances, rearrange themselves to form new products. So if you have the mass of atoms, you can find the how many atoms there are, right? Using the mole, Avogadro's number. You could find how many molecules it would be, and then you can ultimately find the empirical formula as well. And then he talked about this gravimetric analysis. In other words, two reactants that are combining and forming like a precipitate, let's say. So now sometimes we want to work backwards. We want to say if this is the precipitate that formed, I go to the moles of that precipitate and then I can figure out how much this unknown analyte was, or whatever we started with here, how much of it did we start with. Well, here's an example using stoichiometry. So again, if we know that we formed 5.71 grams of the silver chloride, we can go to moles of that silver chloride, then we can go to the mole ratio to find how much calcium chloride we started with, and then of course ultimately the grams of the calcium chloride that we formed using stoichiometry. And this is again something that you already know how to do. Now, if you didn't already try the silver nitrate one as the analyte, you might want to, again, give yourself an extra practice problem here with stoichiometry. So again, we're starting with the 5.71 grams of the silver chloride, going to moles of silver chloride. You already have that information from the past problem we just did, but now it's going to be a 2-to-2 ratio or 1-to-1. But again, I like to use the mole ratio that comes right out of the equation. And from there, we can go 2 grams of the silver nitrate to give us the 6.77 grams of silver nitrate we must have started with. So why is this important? Later on, we're going to be talking about titrations. And titrations are a way of looking at how much acid we have, or a way of identifying what acid we have. So he also talked about at first the acid is being consumed. Again, it's being reacted, but once it turns pink, now we have too much base. Now we've kind of pushed it over the edge and we've went past our equivalence point. And again, we'll talk a little bit more detail about this later, but we have to understand a little bit about titration in order to do the solution stoichiometry. So again, he gave you a titration problem. So we went from milliliters of solutions to liters of solution so that we can use the molarity, right? The 1 mole per liter, the molarity of that NaOH. And then we use the reaction, again, the molar coefficients of the reactions for the 1-to-2 ratio of the acid and base there. Then if you want to know how many grams of that acid that you have, you would use the formula mass and get the answer. Again, practice doing that. So if you didn't try, pause the video and try this one. So it's very, very similar. So you have milliliters to liters. You should know how to do that. Now we have liters of the NaOH. You have liters of NaOH. You're going to use that molarity, very similar to what you just did in the previous section, right? So 0.025 liters using molarity of the NaOH. Now you're using that mole ratio from the balanced equation to give you the grams of the acid that you have, and you do all the math and you get 0.56 grams of the acid. So again, very similar to regular stoichiometry. You have one thing and you're going to another thing and you're using the mole conversion from the balanced equation. The only difference here is, again, you're using molarity as a conversion. So on to your notes packet, and in this section you're going to understand how the concepts of stoichiometry and concentrations now can be used to calculate amounts of concentrations of a substance in solution through a process called this titration. So remember this, right? Again, you're starting with a whole bunch of things over here. You can start with anything. You can start with the number of moles. You can start with density, molar mass. Here is our concentration box. Here is our molarity. So if you know molarity and you know the volume, you can find the moles of substance A. You can use your balanced equation to find substance B. And then, like I said, you can go to any one of these units. So when in doubt, go to moles. So pause the video, fill in the blanks, and then play to hear my words. And again, remember, we should be reading everything, not just filling in the words. So the regular stoichiometry is what you are used to, right? Finding moles, going to one substance to another, maybe dealing with molar mass, maybe dealing with atoms, maybe dealing with 22.4 liters, that kind of stuff. But when we're talking about solutions stoichiometry, now we need to know the solute concentration, we need to use molarity and volume, we need to find the number of moles. So this equation is actually really quite useful. If I want to know moles and I have molarity and volume, I just multiply them out. So here's an example problem similar to what he did in the video. We want to know how many grams of NaOH are needed to neutralize 20 milliliters of a 0.15 molarity sulfuric acid solution. So the first thing I come up with is an equation. I write in what they give me, just like I do any other stoichiometry problem. They give me 20 milliliters of the acid, they give me molarities of the acid, and I want to know grams of the base. All right, here we go. So we're going to using the concentration and volume of the acid, we're going to convert to moles. Basically multiply them out, but now remember, again, they gave you milliliters. You need to use liters in order to use the molarity conversion. And then we're going to use stoichiometry. In other words, we're going to use the coefficients from our balanced equation to go from one substance to another. Okay, so that should make sense there. Now that we're at moles of the base, we can go back to the grams of the base using mole island. Okay, so now normally, ladies and gentlemen, what I would do is do this all in one shot. I would have the 20 milliliters times 1 over 1,000 to get to liters, times the molarity conversion, times the balanced equation mole ratio, times the molar mass. I would have just done it all in one shot, but I just wanted to show you what the steps are. I don't even know. I gave you the answer here. I'm sorry. 0.24 grams of the NaOH is ultimately your answer. So try one yourself. Again, come up with the reaction. Write down what's given to you under the substances, and then see if you can get from one substance to another. Should have this so far. Okay, so, they give you moles of this guy, so you always start with what they give you. Then you're going to probably use this molarity at the end to find the liters of the HCl. Okay, so now that they give you just the moles here, even though they give you molarity here, you're probably going to use that molarity more towards the end to find those liters of the HCl. So here's our starting point. Again, moles to mole ratio to the molarity. Then you can do your liters. There you go, because moles of the lead to nitrate cancel out, moles of the HCl cancel out, and we're left with liters of HCl. So that actually was a little bit easier than the first one. But again, where's your starting point? Where's your end point? You always want to start with information they give you, and you want to end where your question mark is. So what is titration? Well, titration is a way to determine the concentration of a particular solute that is dissolved in that solution. So combining a solution where the solute's concentration is not known with a solution that is known, like a standard solution. So in other words, you know one concentration, but you don't know the other. And it's going to help us get to what's called the equivalence point. And the equivalence point is the stoichiometrically equivalent quantities that are brought together, and that's where that change of color is going to occur. When you're using phenolphthalein as an indicator going from acid to base, it goes from clear to pink, but there's other indicators we're going to talk more about in the future. So what is this equivalence point, or what does this stoichiometrically quantities really mean? It means that our moles of our H plus from the acid is going to equal the moles of the OH minus ions from the base. So that equivalence point is where our H plus acid and our OH minus base, the moles equal each other. And again, that's why moles are really, really important. So you might want to pause the video and kind of look this over. This is another one of those neat flow charts, but what am I going to bring to your attention? Ha. So you can start anywhere here, get to your acid, moles of your acid, go from your acid to your base, and then you can go anywhere over here from your base. So very similar to any stoichiometry problem. This is just a little something extra. Read over that. We will talk about it in more detail, but I want to remind you that NaOH is a really, really strong base, where when I take out the NaOH, it's a solid, and I need to make some kind of concentration with it, it reacts with the water so fast and breaks apart so fast that if I actually mass out 5 grams of sodium hydroxide, it really is less than the 5 grams that gets into the solution, because there's so much water that gets added to the solid that I'm massing out. So it's kind of hard to understand, but it will make sense a little bit later on. But just keep that in mind. So one day when we do our titration lab, we have to actually what's called standardize the NaOH first, because even though I think I know the molarity, or I think I know the concentration of the NaOH, it's really not 100% known, because 5 grams when I mass it out is going to react so quickly with the water in the air that it adds it, just like those nails. When I have those original nails and I leave them out for so long and they start rusting, over time there's more rust, right? It gained mass. Same thing with this NaOH. It reacts so quickly with the water that it gains mass. And then of course my mass is off and my concentration is not what I think it is. So here's an example again of stoichiometry using an acid and base. So what do I have? I have milliliters and molarity of the NaOH. I have milliliters of my acid, but I want to know molarity. So no matter what, I'm starting at my base and I'm going to my acid, because that's where my question mark is. So convert to moles. Use stoichiometry, convert to moles of the acid, right? We start with the moles of the base, go to moles of the acid. And then to determine the molarity, again, we have moles over liters. So here's our moles, and the liters was given to us in the beginning of the problem, and our answer is 0.1 molarity of the sulfuric acid. Again, try the practice problems and then play to see the solutions. Those are the answers. So if you got the answers, you're great. If not, you might want to play the video step by step. Always need a chemical equation. And again, I normally would have put down what I have of each substance. I would have said question mark NaOH for the molarity, so I know that's where I want to go. And I would have put the 35 milliliters and the 0.144 molarity of the H2SO4 underneath it, knowing that that's where my starting point is. Solution for number 2. And hopefully that makes sense. See you in class.